Good morning, everybody. My name is Jonathan Gardner, and welcome to the U.S. Cloud Application Development Partner Community Call for November 2016. Just so everybody knows, this call will be recorded. If you do not consent to be on a recorded call on behalf of the Microsoft Corporation, please hang up now. We have a great call for you today. We appreciate you joining. If you have any questions throughout the call, please use the question and Q&A pane in the link stream, and we will answer those questions as soon as we can. Today's agenda, we've got a really good agenda for you guys. We are going to talk a little bit about DevTest in Azure, and then we're going to spend the bulk of our time really getting deep down and dirty and talking about containers and getting into some demos and stuff. So we've got a really good agenda packed for you guys today with a lot of good technical content. Again, if you have any questions, please feel free to reach out to us. So with that, I'm going to turn it over to our first presenter. I'm not going to dilly-dally. Rodrigo?
All right, thank you, Jonathan, and welcome everyone for the November edition of our Cloud Application Development Partner Community Call. It's a pleasure being here talking to you this morning, afternoon. I don't know where you are in the country, but I wanna make sure that you have insightful information and idea for you to run your business. And even before we start, digging into the subject that I wanna cover this morning or afternoon, I just wanna remind us as application developers or developing applications for either for us or for our own organizations or for customers that we work on a regular basis, the development projects, they usually have a timeline that is impacted in many ways by the lack of environments for testing or the quality of the testing being performed by the users, by the end users, or even by a testing team. So we, as a development organization, face on a daily basis the challenges of doing proper acceptance testing and testing the applications that we're supposed to deliver to our users. And by the way, it doesn't matter if it's an application developed in-house or a package application that we're customizing or an ISV solution that we're deploying to a customer. Every application who needs to interact and integrate with other apps, as well as with users in many different ways, either from mobile, web browsers, and name it. So, or even embedded applications that are running in devices. The challenge that we envision in many of our customers, and I can see that you might also testify that with your customer interactions that you have on a daily basis, is that development or application teams, they face huge challenges in having access to proper testing or acceptance environment, which might make them go and ask for resources to IT. And usually IT tells the difficulties about, procuring or purchasing new hardware, which will cause several delays and compromise the overall success of the endeavor. Some of the numbers that we have been able to identify is that 65% of our developers or development teams or application teams, they says that it's very hard to have access to production-like environments or environments that will mirror production to be able to proper replicate customer scenarios or user scenarios or non-functional requirements or even to make sure that all the software is the same as expected in production. And whenever an application team has access to a development environment, the second challenge that we see is the underutilization of those environments. So environments that are sitting there that are necessary only to a testing cycle, and whenever that testing cycle is not happening, the environment, is costing a lot of money, waiting to be used again. We have seen customers, and also you as a partner, especially if you are a development company, as a solution provider to your customer, there is a clever way for you to address some of the challenges that we see that application teams face. And obviously, the cloud plays a key role here. we try to express 4 or 3 major ways that development teams or application teams might take advantage of the cloud. And the most logical way is to set up developer workstation in Azure. So rather than spend a lot of money in expensive and powerful laptops where developers they can do the work, why not set up VMs in the cloud for those developers to literally, whenever that developer is using whatever device that he or she is using to access that development environment, and then on that workstation, set up your IDEs, your compilers, your debugging, your all the features and tools those folks they love to use. Most importantly, we also have the ability to share the collaborative environment in the cloud by, okay, so what are the code repo that all the developers are using? What is the build process that we have? What is the release management cadence that we have? And how can we collectively, as a team, leverage cloud services to achieve our goals and develop great apps? Last is the pre-production environment. So customers, the dream of every application team is to have a pre-production environment or some type of environment that mirrors production, again, to replicate the most common scenarios. And we know how challenging that is for customers to achieve that. Again, the cloud becomes a natural answer. And you, as a partner, and you as advocating on behalf of the application teams inside your customers, there are 2 ways that we can achieve or can we leverage the cloud to do development tests in Azure. And let me introduce you very briefly to that. So looking at your development community or looking at you as a business partner with Microsoft, you have access to benefits under the MPN. One of the benefits are the Visual Studio subscriptions that you get, again, as part of your benefit. Those subscriptions, as long as you're not using for direct billable activity, so if you're doing internal development or developing a product to sell to your customers, they come with a given amount of Azure credits per month. So every month, each developer that you assign a given Visual Studio subscription has access to Azure, that he or she can create their sandbox. So every developer have access to $150 a month to do whatever they want with Azure, again, in the spirit to develop a better app. So they're going to leverage all the services available in Azure as an individual. Whenever that individual wants to share, wants to have a collaborative test environment so everybody can do testing and acceptance together, that's when we can leverage Azure to host VMs, to host the database. So Azure becomes the hub for the development team or the application team. And while doing that, there is a specific offer called Azure Enterprise DevTest Offer for customers who have an enterprise agreement. And most of you partners have an enterprise agreement in place to be able to test your applications properly. What I'm trying to say is that every customer who have Azure, who have bought Azure previously in credits, are able to leverage that enterprise dev test offer. The links to activate that offer will be shared with you in the PPT, but also I would encourage you to make questions into our Yammer group. I hope you are an active Yammer group reader, so we try to keep that community as much as active as we can, and obviously your participation is extremely important. To give you some numbers, just for me to close my discussion about planting the seed for you as a partner to activate such offer, but also, most importantly, to go back to your customers that you work on a daily basis and invite them to consider activating that offer, which means cheaper Azure for development testing workloads. I want to finish my discussion to, again, encourage you to reach out to us and continue that conversation. So with no further ado, I would like to hand over to our next presenter, and I will be here listening to questions that eventually you guys are making to our moderator, so we can have some time to answer any concerns or questions that you have. All right, so thank you very much for the opportunity. I look forward to continuing this conversation with you through the Yammer questions.
So let's just go ahead and take a look at some of the slides that I have. I have a slide on resources. This is where you could read about Azure Container Service. There is some documentation in using the Azure CLI to deploy the Azure Container Service. And I'll add a few more to these when I get a chance, and you will have a chance to look at it. So let's take a look at here. I have a couple of slides on some data that I found from Datadog. Datadog is a company that does monitoring of VMs, containers, and whatnot. They did a survey and they found a couple of interesting behaviors. I specifically picked a couple of these because after talking to customers about containers and Docker, customers of size like very small companies, startups, to medium-sized businesses, to big companies like Verizon, Starbucks, I could relate to these. So one of the top things that I found was the Docker adoption and how it's grown over the year. If you look at this slide, it kind of shows that it's grown 30% year over year. And the year before it was even faster. So Docker is taking off, pretty quickly. It's very popular. Some people get the value of it and are more than willing to invest to do proof of concepts and take it to dev, test, and production environments. The second slide that I found interesting was about the adoption status when it comes to different size companies. Now, the bar on the left is companies with hosts less than 100. The middle one is with hosts 100 hosts and between 100 and 500 hosts. And the bar on the right is with companies, large companies with greater than 500 hosts. Now, typically what you see in these situations when new technologies come in is smaller companies, adopting more. They are the first ones to get in, do adoption, and try out proof of concepts. But it's the reverse here. It's kind of the bigger companies are also jumping in. They kind of have figured out the value of containers and Docker, and they are jumping in and taking the leap of doing proof of concepts, making using Docker to do development and QA and testing in their development scenarios, handing out to their different teams in the company to try it out. Moving on, what is Docker? What is Docker now? One thing that we have to understand is containers is not equal to Docker. Containers have existed for a long, long time. They've existed in the form of C groups, which is control groups and namespaces in the Linux kernel, and similarly in the Windows kernel. What was true about them was only geeks who understood kernel level computing were able to access them. They were able to start containers, play around with them, and make use of them. Mere mortals like you guys and me were not able to do that because of the skill level we had. Now, what Docker has done is basically made it very simple. They have a set of tooling and a set of simple commands that start and stop containers for us. Like they have Docker build, Docker run, Docker start, Docker network. So they have made it extremely easy for people like us to use. They did not invent containers. They just provided tooling and a packaging format around it. And that's all they did. And that is what is taking off now, and people see the value of it. So let's take a look at some of the advantages that Docker brings. Like what is this Docker phenomenon and what does it bring to us? What does it mean for developers? What does it mean for our applications? What does it mean for the ops guy? What does it mean to deploy applications that are containerized in production? I think some of the simple advantages, like basic advantages, include that it's faster. Now, how much time does it take to start up a virtual machine? It probably takes 15 minutes. What does it take to start up a container? It's mere seconds. If you guys have played around with containers, if you've started a container, basic Docker run hello world, and you've seen how fast it starts up. Or even a complicated one like Nginx or a big application. It just starts up in like seconds. And with the fact that Docker can run anywhere, because it packages up the libraries and binaries and the application in an image format, and the fact that everything runs on the Docker engine, it's more portable. So it runs on my machine, it runs on your machine. As long as you have Docker installed, it runs on every machine. And it just makes it simple, portable. There is no more saying that it works on my system, it doesn't work on your system. Maybe you have to download these dependencies and kind of install them and make sure that it is included in the class path so that you can actually run the application. And because of this set of simple tooling that you have with Docker, Docker run, Docker commands, it's very there are a bunch of commands, but you use only like 10, 15 of them on a regular basis. And what that does is it basically improves your dev cycle. Say you make a change to your code, and then you say, okay, Docker build, and then say you run it and say, okay, it works fine, let me push it to the repository, Docker Hub or maybe another repository that you have, and you push it. Another developer wants to make a change, he's able to pull it from the registry, from the Docker Hub, and then makes changes and pushes it back. So this is already, there's no source control, no checking out code, trying to deploy it on your environment, make sure it works, make sure that all the dependencies are there. So there is no more that. What that means is your dev cycle has significantly improved. Now, what does it mean for the ops cycle? Now, the operations guy are going to do the same thing. They're going to use the same commands on the QA servers or on the production server that they have. They're just going to run the same thing. They're going to run the same set of commands that the developer runs. They're going to do a Docker build and they're going to do a Docker run. And so the ops cycle, with the same set of commands has suddenly become quicker. Instead of trying to do configurations and trying to run it elsewhere, it just becomes simple. And with all of these, with everything, with the portability, with the cycle becoming faster, you have suddenly become more agile. If you take into account, you have reduced the time it takes to build an application and deploy it. There is significant proof of this in the industry out there. There are multiple reports that you could read, but I have certainly found that with also feedback from customers that it makes you more agile. Moving on, this is the slide on the Gartner hype curve. It is kind of broken down into 5 sections. The first section is where there is a technology trigger. Everybody gets excited about the technology. There is hype around it. There is a lot of people using it. Specifically in the case of Docker, it's kind of everybody loves it. Everybody in the Bay Area loves it. They think it's there is so much media hype around it. There are almost articles on Newsstack and Hacker News every other day around it. There is significant venture capital funding into Docker. And so that is what is there in the industry today with Docker. You are at the peak. You are slightly below the peak. I see it like around where the peak of inflated, right behind the peak of inflated expectations. That's where I see. People are still trying it. People are still getting onboarded. So we've not reached the peak of inflated expectations is what I feel. Where it will go, we have no insight into it. It's kind of a very new technology, significant interest, definitely no idea where it is going. Nobody knows, how far we'll go, how well it will do or whatever, but there is definitely a lot of promise. Now moving on, just to show, how different is a container from a virtual machine. Now, if you know virtual machines, it's an entirely, it's in guest OS in entirety. You start up a virtual machine, it actually has its own kernel, it has its own networking resources, it has its own RAM, CPU, everything. It doesn't, it takes hold of the entire resources. Now, to run applications on it, you need to have binaries and libraries and the application itself running on it. and you could run multiple guest OSs on a hypervisor. What that means is they will have their own share of the kernel. They don't share, so they will have their own share of the kernel. On the right is a container environment. Now, what that means is, you see, there's no longer the hypervisor. There's the host OS, and on top of it is the Docker engine.
Sure. Can you go to content mode on Skype so we can see the image on the right? So at the top of the Skype window, you'll see you know what I'm talking about? So
Okay.
everybody, yeah, everybody in the, no, at the very top next to the smiley face on Skype, it'll say gallery view, speaker view, content view.
Oh, okay.
You go to content view, it's, for whatever reason, it's presenting on our side. There we go,
Okay.
perfect.
Okay.
Sorry, that way everybody can see all the graphics.
Oh, okay, cool. Sorry about that.
No worries.
Okay, so yeah. So what I was saying is, this is on the right, we have the way containers are built. So you have Docker engine running on a host system, and what containers do is they share the kernel. What they pack in a container is the application itself and the binary and library. So you pack it as an image, and you can run multiple containers on one virtual machine. They will share all resources. They will share the kernel. And one thing that is key to note is, multiple applications can, share the same binaries and libraries, or they could use different binaries and libraries. Now, what that means is, they are running in isolation. A container that is packaged with its own binary and library, and the application itself is isolated, but they share the OS. And because every time you run a Docker container on a Docker engine, it's kind of, you can move it around. It's flexible to move around, and it can run anywhere Docker engine is there. Any version of, say you have an Ubuntu virtual machine on which you have Docker engine installed. Somebody else has a Core OS engine and has Docker engine installed. There is no difference in running Docker containers that are Linux specific on either OSs. As long as there is a Docker engine, it will run. So there is, as you see, it significantly simplifies the way you build and deploy applications. Moving on, what does containers on Azure mean? The simplest way I say it is, the simple way to start up containers on Azure is to start up a Ubuntu virtual machine. Go to Azure Marketplace in the Azure portal, search for a Ubuntu virtual machine, start it up. Install Docker, and then do Docker version, and you will see Docker running on it. But we also have images in the marketplace with Docker pre-installed on them. So there is an image with, it's called Ubuntu VM with Docker containers. So you could start that virtual machine, and you could directly go to the command prompt and say Docker run, and it will run the image that you want. So that's a very simple way of starting containers on one single virtual machine. I'm sure all of you would have heard this. There was big news on October 15th. Now, Windows Server 2016 also supports containers. It's the same set of tooling. It's nothing different from Linux containers. It's just that they use different set of APIs. Now, Docker on Linux with the same command uses Linux kernel APIs, whereas on Windows, the same set of commands that use Windows kernel APIs. So today, if you went to the marketplace and you started the Windows Server 2016 image, say it's called Windows Server 2016 Data Center with containers. If you were to start that up and go to the command prompt and say Docker version or Docker run, you will see the Docker commands running already on it. But these are cases where you start up single virtual machines and run containers. But in reality, when you build applications, a distributed application or a big application that has multiple components to it, and it is microservices based, you ideally need a more complex environment. By complex environment, I mean you need something like Azure Container Service. Now, what Azure Container Service is basically a cluster of virtual machines, like anywhere between 1 and 100, and that allows you to deploy containers. That has an orchestrator support. I'll get into the details in the next slide. That has orchestrator support, and it will allow you to deploy hundreds of containers on the agent cluster, and the orchestrator will deploy it for you. You tell the orchestrator that deploy me this application. The orchestrator will deploy it for you across the VMs, and will take care of managing and scheduling them. So Azure Container Service today is Linux first. It GA'd around mid-April. Windows support is in private preview today. The GA date has not been finalized. There is another product that we have in Azure which is called Service Fabric. It's a PaaS-like solution. It supports both Windows containers, and I think Linux is coming, but it's more a PaaS solution. I will talk about the difference between Azure Container and Service Fabric in the next slide. When you look at the spectrum of Azure, and you look at IaaS and the PaaS end of it and the whole spectrum, the bare bones IaaS solution is a virtual machine, and this is standing up single virtual machines, and right next to virtual machines is virtual machine scale sets. I'm not too sure if you guys are aware of what virtual machine scale sets are, but then they are basically standing up hundreds of virtual machines with the same configuration using a declarative template, which we call ARM template. You write 100 lines of JSON code and provide all the configuration, and it starts up 100 or any number of virtual machines that you want with the same configuration. Now, Azure Container Service is it's IaaS plus one, as I call it, but it's not a PaaS solution. What that means is it starts up it uses virtual machine scale sets. So it starts up a cluster of virtual machines for you, and it also sets up one virtual machine or 3 or 5 virtual machines where it allows you to set an orchestrator that will deploy applications for you, and that's it. So it's IaaS plus one. We don't force you to build applications in a particular way, as I will show you in the next slide, which is why it is not a PaaS solution. PaaS solutions typically are something like Cloud Foundry and Service Fabric, which hold you to a specific model that you need to program to. So they tell you, like, use these APIs to build applications, and what that means is you are tied to the infrastructure because you are using the platform specific APIs. So Service Fabric and Cloud Foundry are PaaS solution. IaaS is, Azure Container Service is behind them because we don't force you to build applications to the platform. Simply put, Azure Container Service today is, like I said, infrastructure. The base layer is infrastructure. We start up a cluster of virtual machines for you, and then there is the orchestrator layer. Orchestrator layer is basically we have support today for Docker Swarm and Apache Mesos, which has been rebranded as DCOS by Mesosphere. We provide you the choice of these two orchestrators. These are open source software only. We don't use their enterprise editions, and we provide you this infrastructure layer and the orchestrator in the form of an ARM template. So we worked with Mesosphere and Docker guys to take thousands of lines of code to build this infrastructure for you, and just provide it to you in terms of an ARM template, which is like barely 50 lines of code. And so you could start up this infrastructure in like 10 minutes, under 10 minutes. And what this includes is a cluster of virtual machines that are called agents. You could choose anywhere between 1 and 100. And there is a master. You choose 1, 3, or 5 masters where the orchestrator sits, and the orchestrator helps you deploy applications on the infrastructure. When I say 1, 3, or 5 masters, one master is when you don't care about availability and you're just kicking your tires. But when you really are in a production environment, you would use 3 masters or 5 masters for high availability. Now, let's go and talk a little bit about the orchestrators that we have today. Docker Swarm, as you know, is a very popular. It's Docker native. It was released around September last year. There is significant hype around it, and people love Docker. It's not as production proven as DCOS, which is basically it's been proven over the years as an orchestrator. It's used by Twitter, it's used by Airbnb, it's used by Yelp, and a host of other companies to orchestrate container-based applications. So it's more production proven. One of the questions that we get asked is, about Kubernetes. It's another popular orchestrator. It's another orchestrator that people, talk about these days. Basically, they talk about these 3 orchestrators that we have. Now, We at Microsoft, we listen to customers, and if you guys have been following the news, we hired the creator of Kubernetes last couple of months back, and he works with us. So we will see and find an appropriate time to see if Kubernetes fits into our scheme of things, and we'll make it available. One thing to note about Azure Container Services, if you see, we have no insight into the application that you build. We've drawn a line at the orchestrator layer, and we've said that we will give you a rock solid infrastructure. We'll stand it up for you in like 10 minutes, and then you are good to build your own applications. And if you build your applications the right way, if you build them using public APIs, you are not tied to the Azure infrastructure at all. You could, in fact, take the application and run it in any other public cloud. You could run it in your own data centers, and we have no say. But we also have, with our partnerships with Mesosphere and with our partnerships with Docker, we have enterprise versions of those. So, but if you choose to work with enterprise versions of our orchestrators, you could reach out to Mesosphere or Docker, and they will help you, in your path to building applications and on these platforms. So that choice is there, and it's completely managed by the teams out there in Mesosphere and Docker for enterprise grade applications. But you would need them only if you do not have significant, technical capabilities to do that. So that is also available with ACS. With Windows Server Containers, it's pretty much the same. We start up the infrastructure, but today we have only Docker Swarm as the orchestrator. We do not have any other orchestrator. Apprenda is a company that is actually working with, that uses Kubernetes orchestrator, and they have done some significant proof of concepts of using Kubernetes on ACS, on Azure, to run Windows Server Containers, to orchestrate them. So that is a possibility that we might integrate in the future. We are in talks with DCOS folks to run Windows Server Containers. That's probably coming later, sometime in next year, but we have no final date on it. And Windows Server Containers on ACS today is in private preview. And I run the private preview, so if you ever need any access to it, reach out to me and I'll provide access. ACS today, like I said, Linux is generally available. The Windows part of it is private preview. In terms of what we charge for the service, there is no charge. You pay for just the underlying infrastructure, the virtual machines that you create. There's no charge for the service yet. Now, what does Azure Container Service do actually? Like, how can it help you? So this is a good visual, the way to see in how you would use Azure Container Service in a dev test environment. If you look on the left, there are two blocks. These are App 1 and App 2. These are two applications, and you will see there 3 hexagons in there. Now these 3 hexagons of different colors in each of the applications, they represent a container. So say application 1 is probably, you could visualize this as a simple website. The red hexagon represents the front end of the application, which is basically a web view of it, say a JSP that you see. The green button is the middle layer, that does all the processing and can be accessed, and it's a separate application in itself. And the yellow one is maybe the database or a data store that is a container in itself. Now, when you come and you tell Azure, the orchestrator, that run these applications for me, these all exist as Docker containers. They exist in the image repository of Docker or any other repository for that matter. And you tell Docker run. What Azure Container Service or the orchestrator will do is basically do this. It will take, and it has a pool of virtual machines, the cluster that I talked about, and it will deploy them on your behalf. And how the orchestrators mostly behave is they do round robin. So they take each of these containers and deploy them in a round robin fashion on the virtual machines that we have. What that does is it equally, gives us equal usage on all machines and packs containers equally on top of virtual machines. Moving forward, how do you deploy Azure ACS? Now, ACS can be deployed through the Azure Marketplace. I'll share my screen and show you how on the Azure Marketplace you can deploy it using the portal. As I said, this is a quick view of how you do it. Then there is the templates that are open source on GitHub. It's Azure Quick Start templates. You could take these templates and use the Azure CLI to deploy it. Or there is this whole Azure CLI tool that provides you commands to deploy ACS. So there is an ACS command, create command. There is a list, view commands, how many container services you have. There is a bunch of commands that helps you create a container service. You can easily scale the ACS cluster. There's a very simple command in the CLI that allows you to do so. A lot of people have asked us for this, which is why we keep it in a slide. How do you kind of scale in and scale out the underlying infrastructure of virtual machines that you initially create? The CLI is the simplest way of doing it, or you could also redeploy the template with a new agent count. Now let's take a look at quickly. I'll share my screen and I'll show you a demo, and then I'll just show you how you can find the Azure Quick Start Azure template on the Azure Marketplace.
While you load up your screen, we do have a question about containers and
Yes.
stateless workloads versus best practices for stateful workloads like databases. Right. The context is if you're running a database and a container goes down, you lose your DB. What would it look like if you needed to have high availability for a database in that situation?
So just one moment. I can't understand why my screen. Okay.
We can see
So yes. So today in ACS. Formally, like in the resource provider, we recommend that you use stateless workloads. That's because we do not have a storage, a persistent disk story around it. But then in the open source GitHub templates that I showed you, we have a template that is set up to kind of allow you to have disks and use the Flocker plugin for Azure. That will allow you to persist data across containers. We will move it to the RP in a short while, and as in the resource provider. But the right way, like I said, to do is to not to lose your state is to kind of use the Flocker plugin for Azure, and then ensure that once a VM goes down, this Flocker plugin is able to move the volume that you've chosen to another VM and move the container there. The Flocker plugin is there, but it's not very well documented on how to use it. The use of stateful workloads and ACS in the ACS context will be available in the first half of the next year, to be honest.
Yeah, the only other thing that I've seen from a stateful perspective has really been around Service Fabric, but I don't think it's right for the context of a database. So
yes, and there is this whole thing around, do you actually want to containerize your database? That's a question that is a technical decision that you need to make from an architectural perspective. Does it bring in benefits? It's up to you.
Yeah, absolutely. Okay, cool. That was just a question from the audience, and now I can see everybody can see your screen. We can dive into this. I'm really looking forward to it.
Yes. So this is let me talk to you about the simple application that we've built in ACS. This is primarily you see the DCOS version of ACS. So we've started up a cluster with the DCOS orchestrator, and this is the dashboard. What it is showing is how many of the applications that I'm running in containers. And you can see that I have about 6 applications running. The first one is the producer. What the producer is doing here is it's mimicking orders. Like you go to Amazon and a bunch of people, a bunch of folks make orders. So if I start up one container here, what it will do is it will start processing requests. The producer will add them to the queue, and you will see the queue length increase. The next one is the analyzer. What the analyzer does is it looks at the queue. If the queue length goes high, it just scales up and just processes these requests inside the queue. We are using an Azure queue, but you could use anything that you want. Autoscale is an application that is actually monitoring producers, and what it is doing is when it sees that there's a lot of requests coming in, it scales up the analyzer. Now, next one is batch. Now, batch is a low priority job. Now, what batch is doing is, in the background, it is doing some complicated, studies into Alzheimer's and cancer. It's doing some studies around and processing protein information. It's running as a low priority job. And the REST query is basically another container that allows you to, use the REST API endpoint to access the Azure queue. And the web container is the front end that I'm displaying you actually, what it is showing. Now, if you look at what the state of it now, the blue line, the graph on the left, the blue line is the queue length, and the orange line is the processing time to process queues. Now, the queue length is 0, you can see. There's nothing being produced. I have 0 containers running. And if you look on the containers running, if you look at batch, right now there are 5 batch jobs running. That's because there is nothing else running, so why not utilize capacity to, now you can see that the batch was trying to scale up to 6 because there is availability to use the resources, and nothing else is running. So let's take a look at the DCOS dashboard. Now it's showing the, CPU allocation. Now let's see how many nodes I have. In this cluster, I have about 7 to 8 nodes, and you can see how much of it is being used. I have 81% of the CPU is being used, 25% of the memory is used, and no tasks have failed. So if you look at the usability part of it, the efficiency of usage, it's at 81%. If you think back to, at what capacity most virtual machines run, probably they never cross 50. They're running at 40-50%. So using containers, we are demonstrating that you can go up to as high as 80%. Now I'll go back to the application itself, and then I'll say, okay, let me start the producer. Let me start producing orders, and I will just scale it to, say, 2 containers that will produce like thousands of requests every second. And you should see as soon as the container starts up, you will see the queue length going up. One thing to note is you saw how quickly the container started up, and you can already see the queue going up. So the process requests have already started coming in, the queue is going up, and you would have noticed that the queue length is going up, the processing time is becoming higher. The batch job, because it's a low priority job, will start going down because there is there's no more space available to run. So it will at one point in time go down, and the analyzer, as soon as you reach a particular queue length, will start kicking in, running more containers to cope up with the amount of requests that you have. In the interest of time, I will just go ahead and actually scale the analyzer instead of using auto scale, which takes a little bit of time to kick in. So now that I have about anywhere close to 300 queue size, I'll just go and say, okay, let's scale the analyzer to 30 containers to cope up with the queue size that I'm getting. Just a little slow. My screen is not responding, so just give me a while before. It's always a good idea to restart your computer because Windows is slow sometimes. So as you can see, I just scaled up the analyzer. It will take a little bit to, kind of kick in. Yes. As you can see, it's already showing the status. 13 containers have started, and it's starting to analyze, process the number of requests that we have in the queue. You can see that the number of batch jobs have reduced. Batch jobs have reduced to 2. There used to be 5 containers because there was free space. It's a low priority job. Now it's at 1. It might entirely stop because we are using high priority jobs. You can see that the queue is being processed. The length of the queue is reducing. The processing time is reducing. That's because we now have, I started 30 containers for the analyzer. But the auto-scale application figured out that, okay, I need more to cope up with this, the queue that I have, so let me start up more containers. So it's gone up to all the way up to 72. So auto-scale has kicked in itself to start up more containers than I asked it to cope up with the queue. And you can see now that, the queue length has gone down to 0. It will take a while before the analyzer actually scales it down, because now it does not need that many containers to process. So it will take a while to queue down. Let's go ahead and take a look at some of the usage that we have right now. You see the CPU allocation has been flat out at around anywhere between 80 and 90%. This is the efficiency that you get with containers. As you can pack thousands of containers into a cluster of virtual machines instead of trying to run one application that uses only probably about 40%. Most customers that I talk to say they're at their peak usage it's probably close to 50, but never above 50. With containers, you are seeing that you are utilizing resources more efficiently than you would do in a VM, in a situation where you have virtual machines. I'm going to stop presenting right now, and then I will just go back to the slides. Can you help me project this slide deck, please, Jonathan?
Sure, just 1 second.
Are there any questions that I could answer in the meantime?
Not at the moment. I think we're in good shape.
Okay. So yeah, the point that I was trying to make with that application was primarily that the way to run applications on Azure Container Service, which is basically a clustered environment, is to take an application, break it down into smaller services, work independently on each of them so that teams can work independently on each of them and deploy them on a clustered environment. Management of the containers is actually done by DCOS. The orchestrator that you choose should do it for you. There are certain architectural decisions that you can make on it, like how you place load balancers, how you open up ports to the outside world, how you keep some of your containers in an agent pool that is not open to the internet. So there are these bunch of options that you can do with Azure Container Service. Now, comparing some of the architecture, let me just go back and just let's take a look at the OS architectures of Linux and Windows, how it works. Now, Linux, as I said, has used to have, it has had control groups, namespaces, and other capabilities in the kernel for years. What Docker came in and did was build tooling on top of it. They built, Docker client, Docker Compose, Docker Swarm, and some Docker registry. These set of tools basically allow you to kind of access the containers that are in Linux and make it easy for you to run. Now, what Windows did was they did the same thing. They had their own form of control groups, namespaces, but they exposed the same set of APIs that you see on Linux. And so hence what Docker was able to do was use the same set of tools to run containers on Windows as well. And what remained, so what was platform specific was, all this libnetwork, the graphs, the plugins, the storage, the networks, the runc and containerd, all the underlying kernel technologies. But the REST interface that exposed the Docker APIs and the Docker tools remained the same. What that means is you can use Docker tools across the same set of tools across Windows and Linux. Now, one thing to understand is with ACS you can create a cluster that has Linux containers, that has a pool of agents that can run Linux containers, and another pool of agents that can run Windows containers. You can create that. It is important to understand, though, that you can't take a Linux container, run it and run it on Windows, and do vice versa, which is taking a Windows container and running on Linux. And that is, understandable because they are talking to different kernels. They are talking to different APIs. Even the tooling is similar on top. So that's one thing to note. Moving on, what some of the things that are available with Azure Container Service is With DCOS, you have a nice UI. Like I showed you the dashboard. If you go and play around with it, you will see a universe, and the universe actually has multiple solutions for you to use. For example, once you start using containers and deploying your applications, the first thing that you need is monitoring. How do I monitor my containers? How do I monitor my virtual machines? How do I see what's going on? So there are some companies in the ecosystem that provide solutions. Datadog is one very popular company that does. It's very easy to set up. You just create an account on their website, get hold of a few keys, and then come to the DCOS universe and install it on your cluster, and it will monitor your applications on Datadog's dashboard. So what that does is basically, in fact, all of these do the same thing. They will start up a monitoring container on each of your virtual machines, and then through that container, they will take in Docker logs, use Docker APIs to collect all the information about the application that is running and report it back on their dashboard on Datadog. If I had more time, I would have shown you, but in the interest of time, I can't it takes a while to show. The one that is there with a big, the biggest tab that is there is that OMS. OMS is Microsoft's monitoring solution. It's launching in mid-November. It's already there in the DCOS universe. And this is something that you see, it shows, how many containers are running, what are we tracking, what is the CPU usage, how many containers have been created in the last 24 hours, how many have failed, how many have been stopped, all the kind of information that you need will be shown. That's about monitoring. Let me talk a little bit about, the architecture of ACS. Like I said, we have a pool of agents that's on the left. It's on the right. It's built on top of VM scale sets. We have, on all virtual machines, we have Docker installed, and they are trying to. You can access them through the port 2375. We've opened it for you. We have set up the Azure Load Balancer for you, and we've opened ports 80, 443, and 8080 for convenience for you. You can open more ports using the Azure portal. One thing that you will notice that there is a private agent pool and a public agent pool. The public agent pool is good design, which is why we have it there. So instead of directly routing traffic from the application load balancer into the agent pool, we have you kind of set up a load balancer on the public agent that will drive traffic into the private agent. You could use layer 7 load balancer like Nginx or Marathon LB to do that. What that means is you will not be tied to the Azure infrastructure directly. You don't have a dependency on the Azure load balancer that is on top. That is why we propose that you have a public agent. Now looking at the left, that is the master. Like I said, when you create an ACS cluster, you could create 1, 3, or 5 masters, which is where the orchestrator sits and helps you deploy applications. It's in its own, all of these are in the same subnet. Today we have support for bringing in your own custom VNet to deploy your agent pools. There is support for multiple agent pools. You could deploy a public agent pool, a private agent pool with different sizes, and you could use that. Moving on. Even though we've talked a bunch about Docker containers, not everything is a Docker container. There is this, in the industry, there's this famous SMAC stack, which is Spark, Mesos, Kafka, and Cassandra, and these are also containers. Now, DCOS, the orchestrator, can deploy Spark containers, and using their universal containerizer, they can deploy other types of containers as well. And we have customers using these containers. So one thing to note that everything is not a Docker container. Moving on, I'll just talk to you about, in the interest of time, I'll just skip a few slides and then talk about one of our customers. Esri is, they build real-time geoinformational system services. They use ACS and they deploy they they came to us and they said, we want to use ACS because we love the open platform that you have. We love the fact that we are not tied to the Azure platform. We love the choice that you provide us in terms of orchestrators and the flexibility that we have. And what they did is they did a proof of concept in days. They stood up a cluster, they deployed their applications, so what they do is, in this link you will see a demo that they did at Mesoscon. They primarily, what they do is, in a city like New York, they will monitor, using the taxi APIs that are provided, they will monitor taxis, the average trip time of a taxi, the average pickup time, the average drop-off time, most places where you're getting dropped, where you're getting picked up. So they collect all this information as data, which is it's a lot of data, it's big data, and they use the Azure IoT platform to feed in this data and deploy on the ACS cluster, and they get intelligent information out of it and feed it into other customers that they have. They provide this information to the customers, maybe somebody, they actually have used it in with Boston Marathon to provide them information about all the traffic data during the marathon, which could be used to have an impact on how to route traffic during the marathon, where to set up taxi booths, where to set up any kind of booths that might be needed to help people around. So this is like a real use case of us, the Esri using ACS to build their applications. We have other customers like Verizon and Starbucks and a bunch of those who have come and used our platform primarily because of the flexibility that we provide and the open source components that we have. That is one point that strikes out when we talk to our customers, the fact that we are open source. If you look at our competitors, Amazon EC2 Container Service and Google Container Engine, with Amazon, you don't know what you're getting. It's a full PaaS solution. You build your applications according to their standard and the way they want it, and you are pretty much stuck into their platform. They have their own custom orchestrator. You don't get a choice. That's another thing to note about them. And then with Google, they only have one orchestrator, which is Kubernetes. They've tweaked it. They tweak it every time to make it run well on Google with Container Engine. What that means is they are opinionated. They run very well on Kubernetes runs very well on Google. So they are also pretty opinionated, even though they are not as sticky as AWS is. With ACS, like I said, you have the choice of orchestrators. We have everything that you need, and we do our best to provide customer choice. Today, ACS is not a managed service per se. We are working on providing a different SKU that will manage upgrades of software and OS for you, do security patches for you for customers, but that's coming sometime in the future. And we are again open to any kind of feedback. You have my email ID. You can email me with any feedback that you like. With that, I think we are slightly ahead of time. I wanted to thank you all for giving the opportunity to talk to you about containers and Azure Container Service in specific. Thank you so much.
So yeah, thank you so much for coming on the call with us today. I know that we've had some good discussion in the chat windows. The only other question we have as we kind of close things out, we will. Does it make sense to use JumpHost to connect to the master to avoid exposing masters to the internet? Because he's not sure if using an NSG would cause any issues if ACS cluster needs to reach out to the provider in the infrastructure.
No, so the way you connect to a master is you use a SSH tunnel today. So basically, it's a secure tunnel that you create between your computer, your laptop, and the master. So it's not open to the public. It requires a SSH key, so you are pretty much secure out there. Now we are working with with the Azure AD team, authentication team, to provide Azure AD as the authentication platform instead of using SSH to make things simpler. But that's coming in the future. So yes, today you are safe with SSH tunnel and you don't have to worry about the internet accessing your master.
Awesome. And we are 1 minute over today, guys, so I'll make the wrap up quick. If you have continuing discussions on containers, let's bring those to the Yammer group. That is also where we will be posting the recording for today's call, and in the slide deck when we get it all set up will all be shared there. What you see on the slide today is how to connect with us. We certainly want you to join the Yammer group. You can access it there. You're already on the monthly calls. Please join us next month where we are going to talk about Xamarin and bring some of the Xamarin partners in with us as we start to have these application development discussions, and then continue to follow us on the blog where you can get to the link there where we will, our next, like I said, next month's theme will be with Xamarin, so we'll be talking about some of that, so you'll continue to see that. Also, as we kind of close things out, a big thank you to all of our partners. As we close out this this slide, we will be presenting you guys with a survey. So we really hope that that you'll fill those out for us. It helps us shape the content. It's not about how any of us get measured. It is really about how we help shape the content for you guys. So if you'll just hang around for a couple of minutes after, I know we're a little bit over, but if you'll do that and fill those questions out for us, we'd really appreciate it. And with that, we'll let you guys go. Thank you so much.